Good
Nice
evening,
one.
class. My name is
Good
Madam
evening.
Caroline, and I'm going to take you through the topic use of power factor in electrical installation. Are we together?
Yes, we are together.
Our
Yes,
learning outcomes. Are you able to see my screen? Okay.
yes,
Our
yes, we
learning, as
Yes.
per
can.
the screen you are seeing, our learning outcomes are one, definition of terms in per triangle. Objective number 2 is identify per triangle. Now let's go to our first objective. We define some terms associated with power factor. Can somebody tell us the meaning of power factor? Who has an idea of what power factor is? Okay.
Maybe I can try.
Kindly move on.
Is the ratio of active. Nini yako inapotea.
Jeez. Yeah. David.
Is the ratio of active power, apparent power in the word. Power factor is the power usefully employed by a device divided by what is carried to the device through the power grid.
That's a good try. Okay, from my slide, power factor is defined as the ratio of active power to apparent power. In other words, power factor is the power usefully employed by a device, which is represented by letter P, divided by what is carried to that device via the power grid. Are we together? Yes, let's go to the second
Yes,
definition. These are the terms we are going to use when we come to our main topic, which is the power factor. So our second term is the active power. Who can define for us? Who has an idea what active power is? Yes, Jacqueline. Yeah, as per what Jacqueline has said, active power is the power which is actually consumed or utilized in an AC circuit, and it is also known as real power. It is measured in kilowatts or megawatts. We are moving on. Well, let's go to our next slide. The next term we are going to come across is known as apparent power. Who can tell us what apparent power is? Abuga? Am I talking to myself?
Apparent power.
Sorry? Yes?
Apparent power is the power when electrical in an AC system, electrical power in an AC system flows to a load where all of the power is not necessarily absorbed and used to perform useful work.
Wow,
The total power flowing
yeah.
The total power flowing is what we call apparent power.
Yeah, you are very correct. As you can see from the screen, apparent power is the electrical power in an AC system which flows to a load, and all of that power is not necessarily absorbed or used to perform useful work. So the total power flowing to a load is known as apparent power, and it is measured as the force. It is measured by KVA. We are moving on. Well, let's go to the next. The next term is reactive power. Who can tell us what reactive power is? Humphrey,
yes, I can try, teacher.
please.
Yes, reactive power, I think it is the power which flows back and forth. That means it moves in both direction in the circuit or reacts upon it.
Correct. That's very correct. Reactive power is the power which flows back and forth. That means it moves in both the direction in the circuit. Okay, it's measured in kilovolt ampere reactive or megavolt. We are moving on. Well, let's go to the next topic, slide, which is the power factor correction. What do we mean by power factor correction? Power factor correction, an idea. Jacqueline, kindly tell us what power factor correction is. That's very correct. Is what Jacqueline has said. Power factor correction refers to the process of improving power factor by deliberately adding reactants. That's by adding, you add capacitors to a system, to a power system, so as to improve on the power factor. So we go to the topic of today, which is the power triangle. A power triangle is the representation of a right angle triangle showing the relation between active power, reactive power, and apparent power. From the definitions we have just mentioned, we can see, as per now, you have understood what active power is, what reactive power is, and what apparent power is. Now, from those terms, we can derive the formula for finding a factor, which is the active power divided by the apparent power. Okay, from our previous discussion, we have seen that active power is measured in kilowatts, and the apparent power is measured in kilovolts amperes. So to get the power factor, you use this formula: active power divided by the apparent power. Now let's look at the triangle itself and how these terms are represented in a right angle triangle. This is our right angle triangle, and from this is our right angle triangle, and from this triangle you can see this is the true power, which is also known as the active power, represented by letter P. This is the apparent power, which is the hypotenuse of the triangle. This is the reactive power, which is the adjacent part of the triangle. Have we understood? Okay.
Yes.
Yes.
Our last slide. Our second last slide. Okay, it's still explaining on the power factor topic. The portion of power that is absorbed and used by the load is known as the active power and is always equal or less than the apparent power. Remember, the apparent power, what we said about the apparent power is the total power delivered to a load. And it doesn't mean that the power delivered to a load is maximally utilized. The maximally utilized load power by a load is known as the active power, and the total power which is delivered to a load is known as the apparent power. And for every electric machine, it needs the active power and the reactive power to operate. Are we there?
Oh, yes.
Yes.
Okay, a power factor is from the formula. It should be since the active power and the apparent power, they are not their values are not there. The difference, the gap between them is not that much. So the power factor, which is the active power divided by the apparent power, it should give us a value between 0 and a 1. When it's near 1, it means that there is more efficiency in that power system. And it means, in other words, it means the power transmitted is utilized maximally. And again, when the power factor is less than it's leaning towards the zero side there, it's less than 1. It means that the power system is inefficient and it needs some improvement. It means there is much power loss which needs to be rectified. And for the power factor to be improved, the power factor should be improved to be near, at least be near 1. Okay, it should not be 100%. So it should be somewhere near there. So for that correction to be done, it needs some correction, and the correction can be done by adding capacitors. And that's all about power triangle. I hope you have understood. At least you have something. Yeah, you have understood something about power triangle or power factor.
Yeah, thank you.
That's the end of my presentation. That's all for us. See you in my next lesson, which will be about calculations in power factor correction. Okay, bye.
See you.
Bye.
Thank you, teacher.
Let's see background.